So in our past modules, we've talked about the law of sines and the law of cosines. What I want to talk about now is how to apply those law of cosines, the law of sines and the law of cosines. So let's start with this problem right here. A surveyor needs to measure the width of a building. He identifies the points E and F at ground level on opposite sides of the building. He then walks to a point a distance away from the building, point G. He measures the distance from E to G as 284 feet, the distance from F to G as 322 feet, and the measure of angle G as 63 degrees. How wide is the building? So, it says round your answer to the nearest foot. So what I like to do is anytime you have a problem like this, especially in trigonometry or geometry, wherever, first thing I like to do is draw a picture. I'm going to imagine this is kind of a wide building. Here's a door, here's all its windows. I don't know. So the surveyor has identified one side is E and the other side is F. He then walks to a point away from the building, let's put it right there, and call it G. He measures this distance right here to be 284. This distance right here to be 322 feet. I should put feet, so I should put my units on there. Then this angle right here is 63 degrees. What we want to do now is we want to find how wide is this building. So what we have here is we have a side, angle, side. So if you remember what uses side, angle, side, law of cosines. So we need to use the law of cosines to find that length. I have everything here marked as E, F, and G. Our formulas for law of cosines are marked A, B, C. So if we don't feel comfortable with A and G, if you're not liking E, F, and G, change everything. And let's say I'm going to call this right here A, call this right here B, and call this right here C. Then opposite little angle A is little a, opposite little b is little b, and opposite little c, or angle C is little c. So what I'm doing here is I'm actually trying to find angle C. Now look at your formulas. Which formula is already solved for angle C? Or for side C. We're not looking for angle C, we're looking for side C. And that formula should look like this. C squared equals A squared plus B squared minus 2 times A times B times the cosine of C. So plugging that into the formula here, C squared is equal to A squared, which is 322 feet squared, plus B squared, which is 284 squared, minus 2 times 322 times 284 times the cosine of 63 degrees. And again, to solve for C, we just want to take the square root. So right there, that is what I'm going to come over here and enter into my calculator. Square root 322 squared plus 284 squared minus 2 times 322 times 284 times the cosine of 63. Right, there's my answer. Come back here and say C, oh shoot, I forgot what it was, short-term memory, 318 feet. Does the answer make sense? It is kind of a wide building, but yeah, 318 feet. I guess it'd be like measuring how wide the school is. Something like that. Okay. Next problem deals with the Leaning Tower of Pisa. The Leaning Tower of Pisa, which is 55.8 meters tall, currently leans to the southeast. When the angle of elevation of the sun is 42 degrees and the tower is leaning toward the sun, the tower's shadow is 57.9 meters long. How many degrees does the tower lean? Round your answer to the nearest degree. So again, I would start off by drawing a picture. I would start off by, I like to do this. I like to put up the sun up here. I know it's a little cheesy, but it's fun to draw pictures. This is when your inner artist can come out, and you know that Mr. Lems is not an artist at all. Then the Leaning Tower of Pisa kind of leans towards the sun. It's kind of a small lean toward the sun. Angle of elevation. So, and then its shadow is going to be this way. Angle of elevation right here is 42 degrees. So I'm going to put a 42 degrees right there. The shadow is 57.9 meters. The tower is 55.8 meters. Okay. We want to know how much the tower leans. So really kind of what we're thinking about here, let me get a different color here. If this were horizontal right here, we kind of want to know what that angle is right there. It's leaning just slightly right there. So what we need to actually find is this whole angle right there. And then I know this much of the angle is 90. And so to find out how far it's leaning, I just need to subtract 90 from the angle, from that whole angle right there. So how do we find it? Well, let's label our triangle A, B, and C, because all our formulas are in A, B, and C. So that's how I'm labeling it. Okay. So we have to kind of think about what we have. There's a side angle here, so I can't really use the law of cosines. So let's use the law of sines. What is the law of sines going to do for us? Well, first thing the law of sines will do for us, we kind of have to go around this the long way here, is I'm going to need to first find angle A. Using the law of sines, I think I can find the angle A, if you remember that. I should label the rest of my triangle here. So across from angle A is little a, little b right here, and little c. That's what I would do, is try to look for angles if you can. I can find the law of angle A using the law of sines. So I would say the sine of A is equal to its opposite side, 57.9, over its opposite side, okay, is equal to, again, now I want to find, and law of sines is really helpful because now I know both big B and little b. And so when you know both a side and an angle, the law of sines is really helpful. I'm going to say this is the same as the sine of b over little b. And we know what b is. I should write that in here instead of just b. We know b is 42 degrees. Multiply both sides by 57.9. I'm going to say, then I'm going to use the inverse of all of that. Okay. So I'm going to go to my calculator. Get rid of this here. Clear all. I'm going to go into function again and get inverse sine. Go back to main, get my thing here. Say the sine of 42 divided by 55.8. And I'm just tapping next to that to get my cursor to move there, and I'm going to say times 57.9. What are we getting? About 44 degrees. So A, the measure of angle A is equal to 44 degrees. We're not done yet. We want to know what the measure of angle C is. Not angle A. So again, to find angle C, right here, what do we know about the angles of a triangle? We know they have to add up to 180. So if I do 180 minus 44 minus 42, that should get me what I want. So 180 minus 44 minus 42, and we get 94. So measure of angle C is equal to 94 degrees. Still, we're not quite done yet. What was it that we had to do to figure out what this little teeny tiny angle was? 90 minus 94, which is 4. So the tower leans at about an angle of about 4 degrees. Hopefully this will help you. There's a couple problems on Canvas for you to work through for applying the law of sines and cosines. Go see what you can do.